It's science, folks. We have Professor Don Williams here from Fresno State Physics Outreach. It's a group on campus that teaches students how to teach science.
Exactly.
All right, so we're here today. We're talking magnetism and electromagnetism.
We are going to eventually get to electromagnetism, but we started out with this giant magnet we had to bring in, you know, because everybody likes a big magnet.
This is a magnet.
But these are what you're more used to, like the kind you can stick on the refrigerator, right?
Yes, yes.
Those are what we call permanent magnets.
Okay.
Really, all right? Now, if I take a permanent magnet and I break it apart,
yes,
it still is a magnet.
Yes.
It still has, and do you remember, is it plus or minus charge or north or south poles on a magnet?
Plus or minus?
It's close. North or south poles. North or south poles. Now,
all right,
here's what we're going to find out. It's just like in marriage. Opposites attract, right?
Yeah.
Yeah, you know, same old thing. So I'm going to take this magnet. I'm going to pull this one off on top here. I'm going to pull actually a few of these off on.
Okay.
And I'm going to see what happens when I set one of these down on the pencil and see if it repels or attracts. Let's watch. Attracts. So we know there must have been a north and a south pole.
Those are opposites.
Exactly. Now, since I switched it, now they're going to be like, look at it now.
Those are alike.
You
okay.
see how that?
They're repelling each other.
Exactly, they're repelling each other. I could try another one here, right? That one's stuck, but if I pull it off and I go the other way, it's going to repel too, isn't it?
Those are the same side.
Exactly. So that's what it's all about, permanent magnets.
Okay.
Always north and south, right?
Okay.
Now, you guys know how they pick up different things now.
Yes.
Now, this one is incredibly powerful. Since you're standing right here, take a look at that.
Oh, my goodness.
Can you believe that? Now, I want you to take that out of there. See how much that takes.
Oh, that's really hard.
That's just one piece. Look at that.
Oh, my God. Oh, my God.
You see what I mean?
That's really hard.
You're not a kid. What if I did this and I put a few
You
in
know
there?
I like to lift heavy, so I didn't think it was going to be that hard.
Now grab all three of them. Let's see if you can get those off. I'll hold the magnet, man. Come on, you're pulling one too. Oh, you're all right.
My hand. Oh, my God, that was so hard.
That's how strong magnetism is. It's incredible, isn't it?
That's so strong.
It is. It's very powerful. Now, you can't see the magnetic field.
No.
We saw that. But that's what this little device is. It's just a bunch of compasses.
Okay.
And I can put it in front of the magnets, and you can see how it shows the magnetic field.
It's really far away, too, so it must mean that it's very strong.
It's very strong, and it's showing the magnetic field all around that magnet. That's
okay, so that's magnetism.
That is, and then here's another
Here's
little
another.
one. I can show the same
hey,
thing.
look at all those little guys.
Now, these things are where originally magnets, they found out about it. These are called lodestones. They're actually come out of the earth, right? And they're magnets, too. They'll stick to metals like this and stick to another magnet.
And they occur in nature.
In nature.
All right.
I let you feel those. Of course,
they're heavy.
They're heavy. They've got like iron in them, right? They're very, very heavy. Now, this is the kind of magnet you used to see.
Oh, I like that one.
Exactly. You used to seeing this kind of magnet, and it'll pick up a paper
that
clip
reminds me of like Looney Tunes.
Exactly.
All right.
Exactly. That's the normal kind. Now, here's what our next kind of magnet is. We're going to make magnets with electricity.
Okay.
See, that's the thing. You've probably seen in the junkyard where a big truck or a big crane can pick up something
up.
And then it can release it, huh? So you can turn it on and off. See, you can't turn these on and off, can you?
No.
You can't turn them off. So what I'm going to do, and these people can make this at home, is you just need a power source. You need electricity, okay, battery. Wind up a coil of wire, folks, all right? And then a nail. See, I've got a nail.
Yes.
Because it turns out magnetic fields are extremely powerful at points. Just like you've heard of lightning rods and things like that, right? Now I'm going to hook the battery up here, and I'm going to see if this thing becomes a magnet. And it picked up the paper clip. And if I let it go, it's no longer going to be a magnet.
It doesn't have the charge anymore.
Exactly.
Okay, so did somebody see, you know, we discovered the magnetism, and then did they try to say, how can we harness that and be able to control it so we can turn it on and off?
Exactly.
Is that how that happened?
A guy by Faraday started messing around, and he found this relationship between electricity and magnetism. Exactly.
Okay, so this one, the battery plus and minus.
Exactly. It makes a magnetic field.
Okay.
You're getting that. See, we're heading that way.
All right.
Because here is a big one of those. Can you see the wound up wire
yeah, that's
here?
a lot. Yes.
It's a whole bunch of them.
Very fine and tiny.
Plus
we have power.
Big power now, right? And now, right now, it's not a magnet, but when I turn it on, it becomes a magnet. So right now, it won't hold it. But then when I push the switch, it becomes a magnet.
Now it's a magnet. Now it's off.
Exactly. Now, here's what I want to ask you. When you take aluminum, aluminum doesn't stick to magnets, doesn't it?
No.
Certain metals do not, like copper, stainless steel. So if I put aluminum on there and turn it on, and I'm going to let you hit the switch, will that affect that at all? Let's see what happens.
Oh my God! I knew
You saw
something.
that, huh? You knew it was going to fly.
I knew something like that was going to happen.
You knew Don, he was going to do something like that, right?
Yes.
Exactly. Now, here's the key. I could actually make the magnet stronger
By
putting the nail like in it, right?
Okay.
Amplifying it. All right, I'm going to catch it. Shoot it up there. Go ahead. It won't go that high.
Rick over there is like, please don't break anything.
1, 2, 3.
Oh! Oh
You see how high that went?
I did. Why does that happen?
Because here's what happens. It's a lot to do with it. When I put it on here, when I originally turned the magnet on, this feels the magnetic field, even though it doesn't interact with it. It generates electricity in it that makes it a magnet that doesn't like the other magnet.
It doesn't
so
like
I
it.
get the heck out of there.
Interesting.
Exactly. Now, I got a super duper one, Emily. See this one here? I'm going to see if I can hit those cameramen over there, all right? All right, let's see if those cameramen
the prompter was broken. The camera's going to break.
1, 2, 3. Oh, is it still plugged in? It's still... Oh, you know, look
all
at
right,
this.
why did that one not work?
Look at, you know why. You can
really,
see, can you see the crack?
Oh, it's broken.
It has a crack in it. It's hard for the audience to see that, but that has a crack in it. And so sure enough, the current can't go all the way around that. Exactly.
Oh.
Now, we've got one more thing Anand wants to show you. He's going to take this hoop
So you
down
see
here
how
with this
we
big net.
took electricity to make an electromagnet?
Yes.
Do you think we can take a coil of wire like this and make electricity?
Yes, I do.
Here, give it a try.
I believe.
Run it through the coil right there.
Wait, like this?
Yes.
But
And
you
you
got to
can
go
see.
back and forth, up and down. Look
Oh
at
my
that.
goodness!
You're making light. You're
Electricity
creating light.
right there.
So, okay, the power between, or the energy between these two magnets is getting captured by this wire.
Exactly.
And it's manifesting into light at the very end.
Exactly.
Look at us.
that science?
It's
It's
Just
science.
like how we have
Beautiful.
the magnetic field in here,
Yes.
creating electricity, you're using a magnetic field there to create
Here
electricity
to
in there.
capture it. That's incredible. It's science. Okay, Don Williams and Nan, thank you so much. Everybody else stick around because we actually have more science. Fresno State's Physics Outreach is back after this. Stay tuned for this hydrogen gas combustion and a disappearing spoon. We'll show you how they do it. Stay there.